In this video, I'll explain the concept of exponents. Exponentiation, or applying an exponent, is a mathematical operation that consists of multiplying a number or a variable by itself a certain number of times. Let's look at an example. 2 exponent 3. You might have also heard the expression 2 to the power of 3. It's the same thing. The number 2 is called the base, and the number 3 is called the exponent. The exponent's value represents how many times the base is multiplied by itself. 2 to the power of 3 is equal to 2 times 2 times 2. The answer is 8, and we call the answer the power. Here's another example, but with a negative base. Negative 3 to the power of 5. The base is negative 3, and the exponent is 5. This means we need to multiply negative 3 by itself 5 times. The power or answer is negative 243. Notice that the negative 3 is inside brackets. These brackets are very important. Without them, the base is 3 and not negative 3. According to the order of operations, 3 to the power of 5 must be calculated before dealing with the negative sign. Here, it is only 3 that is multiplied by itself 5 times, not negative 3. In this case, the final answer gives the same power as if there were still brackets, but that's not always the case. Let's try negative 2 to the power of 4. The base is negative and the exponent is even. Multiply negative 2 by itself 4 times. This gives 16. Now let's see what happens if the brackets are not put around the negative 2. If the brackets are removed, the base is 2, not negative 2. This time, when completing the calculation, the power is different. When there is a negative base, the answer or power can be positive or negative, depending on the value of the exponent. If the exponent is even, the power will be positive. If the exponent is odd, the power will be negative. Be careful. If there is a negative sign in front of the base, but no brackets around it, the power will always be negative. Exponents can also be applied to variables and terms containing variables. For example, 2a to the power of 5. Here the base is 2a and the exponent is 5. So multiply 2a by itself 5 times. To do this, start by multiplying both coefficients together, which gives 32. Then multiply a by itself 5 times to get a to the power of 5. The power is 32a exponent 5. There are also 2 special cases, the exponents 1 and 0. Let's take 6 to the power of 1. The base is 6 and the exponent is 1. This means that the number 6 is only present once, so the power is 6. Whether the base is negative, a fraction, a decimal number, or if it contains a variable, if a base is raised to an exponent of 1, the power is always equal to the value of the base. Now let's look at the case where the exponent is 0. For example, 5 to the power of 0. To understand this special case, let's look at the following proof. Start with 5 to the power of 3 and decrease the exponent by 1 several times. 5 to the power of 3 is equal to 5 times 5 times 5, which is 125. 5 to the power of 2 is equal to 5 times 5, which is 25. And 5 to the power of 1 is 5. Let's stop here for a moment. Notice that every time the value of the exponent assigned to the base is decreased by 1, the power is divided by 5. For 5 to the power of 0, we must decrease the exponent by 1 again, so we still have to divide the power by 5. This gives us 5 to the power of 0 is equal to 1. Whether the base is negative, a fraction, a decimal number, or a variable, if it is assigned an exponent 0, the power always equals 1. If we continue to subtract 1 from the exponent value, we'll get negative exponents. Let's see what that does to the power. For 5 to the power of negative 1, we decrease the exponent's value by 1 again, so the power still has to be divided by 5. This means that 5 to the power of negative 1 equals 1/5. If we continue this way with 5 to the power of negative 2, we get 1 over 25, or 1 over 5 to the power of 2, since 25 is 5 squared. 5 to the power of negative 3 is 1 over 125, or 1 over 5 to the power of 3. Basically, when the exponent is negative, the power is a fraction. The numerator of the fraction is 1, and the denominator is the original base assigned to the same exponent, but positive. So to sum it all up, an exponent can be a positive or negative number, like we just saw, but can also be a fraction. To find out more about exponents and the laws of exponents, check out this crash course.